Here is question 2b, part 2. So our question is looking at our bivariate graphs, looking at the weights and heights of athletics competitors and swimming competitors. And the question itself talks about, on the graphs themselves, can you draw a line which best approximates the relationship between them? One for athletics, one for swimming. So I want to do a line of best fit for both graphs, and I want to do it so that I've got about half of the data on one side and half of the data on the other side, so above and below the line. So here is a line I think will work for the athletics. I don't want it to have a slope too much lower than that because there's so many data values up the top that I need to take into account. For the swimming one, it's much easier for me to just fit a line straight through the middle there. That works much more nicely. So that's the first part. Let's have a look at the second part. The second part is to comment on their appropriateness and whether some other model would fit best. So I'm going to start just by looking at the athletics competitors, and then I'll do the swimming competitors next. So for our athletics competitors, what I want to do with the graph is I want to draw a line around the data, kind of enclosing the data to get enough feel for what the trend looks like. Kind of like joining the dots. The only thing is, I'm not going to look at, there's a few data values that are kind of outliers that I'm just going to leave off. Okay, I'm not going to worry too much about them because I want to get a feel for where the bulk of the data is going. So looking at that, now I want to put a line of best fit in. And in this case, I don't think I want a straight line because it looks to me like a curve might be better. So that's what I'm doing here, is I'm putting a curve in. And I think that fits far better than the one we had on the previous slide. So now we need to make a comment about which is appropriate and whether some other model will fit best. So we can say, looking at our graph of the heights and weights of the athletic competitors, we think a nonlinear or curve relationship is going to be more appropriate. And now we need to justify that. So this is because as the heights of the swimmers increase, their weight increases at a greater rate. So it's not increasing, it's not a steady gradient. If you think about a slide, it's not a straight slide, okay, or not climbing up a straight mountain. There's a change, the gradient is changing for different heights. And that's our justification for being a curved relationship. Now we want to do the same thing again for our swimmers. So let's have a look at our swimming graph here. And again, I'm going to do the same kind of thing. I'm going to draw a graph around the data and encapsulate that data. And looking at that, I think a straight line actually fits rather well for that one. So that's what I'm going to say, is that looking at the graphs of heights and weights of swimmers, I think a linear graph is appropriate. And I want to say, because as our height is increasing, the weights are increasing at a constant rate. So then we need to compare then we need to look at the marking of this. How does the marking work? So if we drew our line of best fit with a positive gradient for both the athletics and the swimming, and it could have been a straight line or a curve, that would get you U, an achieved level skill. If you comment on the appropriateness of one of the model, so either swimming or athletics, then that would get you an R, a merit level. If you were to comment on both models and justify why the athletics is non-linear, then that gets you the excellence, the T.